2, 1.
Oh, hi. Didn't see you there. I'm Michael.
Hi, I'm Julio.
I'm David.
I'm Anthony.
And we are Team Kangaroo.
All right, so a little bit of background. We're basically working with tractor diagnostics. So right now there's a problem where farmers can't fix their own tractors. So say like a sensor might go like wrong or start sending bad signals. But even though there's nothing mechanically wrong and there's nothing critical to the operation of the tractor, it still prevents the tractor from like actually working. So right now they have to call out a John Deere technician. They have to basically pay them lots of money, and it's really time consuming because like you have to go to the physical tractor. And yeah, so basically we're just trying to make something that farmers can like use to solve it themselves and diagnose which sensor's wrong so they can replace it. So a little bit like our end goal kind of just said, we basically want to make like a box that's a Raspberry Pi. We did that basically to prevent, so we didn't have to deal with like different operating systems like Windows, iOS, if you want to use your phone, all that stuff. And so our goals are to make a GUI, to make a database full of codes, like correct codes. So like, you know, if you have a broken tractor, you want the correct codes to match stuff up against. To decode some of the codes, hopefully, and to develop a consistent testing procedure. And we work for ifixit, Chris Klein, pretty much, yeah. And this is like a box diagram. So you got the tractor, goes to the board, goes to a Raspberry Pi, which connects to our database, and we're thinking a laptop is like an optional interface.
All right, so a little bit more on the actual CAN bus. This is the way that tractors and most cars communicate. So if you've heard of the term OBD2, it's the onboard diagnostic tools, and we can get into it. So it's a standardized protocol that's been around for more than 30 years. So the way that it works is we're really just looking at 4 different sections. So the arbitration ID, which is how do you identify the packet? And usually the smaller the ID, the higher the priority is. So you can imagine something critical to the system will give off a smaller address. And then you have 3 other fields that we're looking into. The more important one is the data itself. It's up to 8 bytes. So we have 64 bits that we have to see how they're triggered specifically for which address. So we have to decode those 64 bits and see it could be 2 bits that just trigger on the gas pedal or maybe more. So we have to reverse engineer those bits manually and see what bits correspond to what signal. And we'll go a little bit more into detail on how we plan on doing that right now. So basically the progress we've accomplished so far is we've installed this thing called PolyCAN that was made previously. And we've done it on a Raspberry Pi, also on Windows, so we're able to capture logs from the tractor itself. We have to manually go there, connect our Cannibal board that you previously saw. And the way the further things that we're kind of looking into, as once again, is the GUI development for ease of use ease of use for the farmers. So when they go and they capture these packets, hopefully we will have decoded them by then, and they'll be able to just see which code pertains to what signal. Another thing we're working on is a database development. So have an organized code set so once again, we're only working with 1 tractor right now. As you can imagine, there's multiple tractors, not just 1 brand also. So we're gonna have to sort those out, and that's why we need the database to see what codes correspond to what tractor and what brand. And more testing on the development. So that what that means is coming up with procedures to actually get codes for the tractor. So for example, the tractor we're testing is working 100% as far as we know, and we can't get bad codes. So we have to trigger those codes ourselves, but we also have to be careful in how we do it. We don't want to break it till the point we actually have to call a John Deere technician. So the project has been split up. The GUI is going to be mostly, once again, on the Raspberry Pi. We're going to be using cross-platform Electron framework, which will help us develop some sort of GUI on a 7-inch screen for the Raspberry Pi, and farmers can see all their codes and have an onboard diagnostic tool that's easy for them to use. The database is going to be using some SQL or SQLite, depending on which one. We're still figuring that out. And that will allow, once again, for the different people also who have access to this code here or these boards to upload their code base up online, perhaps start some sort of forum where they can all share different codes and troubleshoot and help them. So we're kind of helping out establish an open source community and sharing codes amongst farmers. And then the testing, once again, we're just going to be doing that by capturing it into CSV files.
All right, so for materials and tools, as previously mentioned, we're using Polycan, which is what the last year's team prototype, and we're continuing its development because it makes the raw data that we read from the tractor to make it much more manageable and readable, and that way it'll make it much easier for us to decode versus just reading the raw data straight and decoding that. As for the tractor, it's owned by the Bray department. It's a bit old, about 10 years, but theoretically with our process, it should work for all the John Deere tractors because they follow the same protocol. And to actually read the packets from the tractor using a cannibal board, which is used to capture the CAN signals from the tractor. And this is optional. Like, you can also set this up on your laptop, but like this might be cheaper and portable for farmers to use, which mainly consists of a Raspberry Pi and an LCD screen to read the codes, and then like the standard USB and a micro USB cable, and an SD card, which is optional if they want to store the logs locally. And this isn't all of the requirements, but we just want to highlight the important ones. One which is portability. We want to make the software as manageable and user-friendly as possible, with also like minimal effort to set up, because we won't want to give farmers issues first before figuring out the issues on their tractor. And it's also important to us to make better, because initially it took us a while to actually set up Polycan, and we want to make the transition a lot smoother and much shorter for the next year's team to use in case they want to use it. And then for code decoding, which is arguably the most important requirement, we need to code the CAN bus signals accurately so that we know like what specifically is wrong with the tractor. And this requirement kind of comes with sub-requirements. First one being gathering the data, which we need to accurately gather, so that, because if that was inaccurate, then like we can't depend on our decoding process to be accurate either. So we need to make sure like each packet is captured accurately. The next one is translating data. We need to translate the raw data into like a readable hex string, and that way we can organize which bits are which according to that string. And then after organizing them, we need to decode further based on the J1939 CAN protocol, so that we can pinpoint which specific signals belong to like the different functions of the tractor. And then once we get that done, then we can scribe trouble codes, which that means, okay, it's this part of the tractor that's malfunctioning, and like they could research further as to like why that's malfunctioning.
So we have our kind of like makeshift timeline here. To reiterate on the ongoing tasks and tasks we've already accomplished this quarter, we started off with reading the old team's documentation. We then installed Polycan, and then we did some dry runs on the tractor, and then we made a plan of attack for next quarter. You can see up here that we all split the tasks into three overall objectives. One, Julio will be tackling the GUI, the user interface for testers to use in the future. Then Michael and David will be establishing a database, as they've said before. They'll be working hand in hand, so their timelines are similar, as you can see up there. And then for me, I'll be gathering data from the tractor, so that's including going up to the tractor, plugging it in, and then taking that data and analyzing it and handing off to Julio so that he can put it in the tool that he'll be making, so that we can further decode the engine tractor stuff. Challenges that we have faced and are currently facing: one, we are unsure whether the data is accurate. We'll have to go up to the tractor, get raw data. One person that we are handing out the data off to, his name is John, and he's in Idaho. He's a software developer. So he'll be helping us analyze the raw data as well. And as well, we'll have to do it ourselves to make sure that we can replicate the results that the previous team had done. Another challenge that we'll face is the gap, or we have faced, is gaps in documentation. Getting set up was not a breeze. There was some things that the previous group had not documented and that we need to write down so that, like David said, future groups can and will be able to catch up quickly more than we did. And another challenge that we faced that Julio talked about earlier was now having a broken tractor. There are some operations of a tractor that will cause it not to operate if we do cause a fault. So we need to attack the less detrimental ones, which can be like a gas cap, in a car. You can run a car without having a gas cap on, and that won't cause it to not turn on. So we can do stuff like that to figure out whether our codes are working or not. Before the questions, I just want to say that I think the challenges are not hard to overcome. We will to get them done before, or to overcome them and find workarounds in the winter quarter. Now, do you have any questions?
So did the previous group ever decode the code, or were they only interested in passing?
Yeah, they had templates, but again, we're not sure if they took that raw data, and if that raw data is accurate, and if they formatted it correctly. They had a template of like high beam fuse and gas and idling and stuff like that, and they had it in a nice hexadecimal format for us to read. But like I said, I want to go back, get raw data, and see if we can replicate the results. It doesn't prove that it's right, but at least we know that we can follow the steps that they had.
Do you know if last year's group was the first group to work on this project, or like how many?
There's two before us. One, the first group just used like an oscilloscope. They went out there and they're like 5 minutes, 11 minutes. Yeah.
So last year was the first group that had like made the new design choices for the.
All right. Thanks.